Alright, let's look at some special factoring rules. As always do the pre-steps first. Make sure the terms are in descending order with respect to the variable and the exponents for the variable. Make sure your lead coefficient is positive. Always factor out the greatest common factor. So let's look at trinomials, 3 terms, and let's check to see if it's a perfect square trinomial. We're going to do this example first. Let's look at the format that this is in. Notice this says plus or minus, and then over here it says plus or minus. If this is a plus, it's on top, then it's a plus over here in the answer, because it's also on top. If this is a minus in this middle term, then the answer is also a minus. Notice that this first term is x squared, that's a perfect square. The last term is a squared, that's a perfect square. If you take their square roots, you'd get a and x. If you multiply them together and double it, you get this middle term of 2ax. If those things are true, this is a perfect square trinomial, which factors into the square root of the first term and the square root of the last term. The sign of the middle term goes in the middle, and the whole thing is being squared. So let's do an example. If this is going to factor as a perfect square trinomial, we got to ask ourselves 3 questions. Question 1. Is the first term a perfect square? In this case, is it? Is 4x squared a perfect square? It is. Not only is it, we're going to also write down what its square root is. So it is, and its square root is 2x. Second question. Is the third term, the last term, a perfect square? So in this case, the last term is an 81. It is a perfect square. Its square root is 9. The third question is a little more complicated. Is 2 times the square root of the first term times the square root of the third term, is that equal to the second term? Let's see if that's true. If we take 2x times 9, we get 18x. If we double it, we get 2x times 9, which is 18x. If we double that, do we get the middle term of 36x? We certainly do. So that's true. So if the answer is yes to all those questions, it's a perfect square trinomial. This is how it factors. You have one binomial. You put the square root of the first term in this first position. It's 2x. Put the square root of the last term in this last position. You put the sign of the middle term, which is minus, between them, and it's squared. So this is the factored version of that problem. The difference of 2x and 9, quantity squared. Let's flip your paper over and do a couple more examples. Let's look at binomials now. As always do the pre-steps first. Write the terms in descending order with respect to the exponent of one of the variables. Make sure the lead coefficient is positive. Factor out the greatest common factor. If it's a binomial, it means there's 2 terms. A couple of the special rules for binomials. Actually, the only rules for binomials that I know of. The problem could be the difference of 2 squares means a perfect square minus a perfect square. Could be the difference or the sum of 2 cubes. Got a perfect cube and a perfect cube, you're either adding or subtracting them. Let's first look at the difference of 2 squares. This example is 9x squared minus 25. To determine if it's a difference of 2 squares, there's 3 questions that you ask yourself, very similar to a perfect square trinomial. Question 1, is the first term a perfect square? If the answer is yes, then write down what its square root is. In this case, its square root is 3x. Question 2, is the last term, or second term in this case, a perfect square? The answer is also yes, write down its square root. The third question for this is much simpler than the trinomial. Is it a difference? I'm going to use the symbol subtract for difference. Yes, it's subtraction. If all those answers are yes, then this factors very simply. It factors into two binomials. You put the square root of the first term, 9x squared, in the first positions of your binomial. It's going to be 3x and 3x. You put the square root of the last term in the second positions of your binomial. Make one of these plus and one minus. It does not matter which one is which. Let's do a couple more examples of difference of two squares on the back of your notes. Sum and difference of two cubes. Let me point out the part here that looks probably the most vexing to you. This is plus or minus. Notice the plus is on top. So if this is a plus, anytime over here on the right I have a choice for signs, I choose the top one. So if this is a plus, this one's a plus, this one's a minus. If I choose the bottom sign here of a minus, then this bottom sign I choose here, I choose this bottom sign. Notice this last one doesn't have a choice, it's always positive. As an example, I have x cubed plus 8. To be a sum or difference of two cubes, it's basically the same questions that we just did for the difference of two squares. 1 is the first term of perfect square. 2 is the last term of perfect square. 3, this could be a sum or a difference, and it's always going to be a sum or a difference. So I guess that's pointless to even say that. We just got two questions. X cubed is a perfect cube. Its cubed root is x. 8 is a perfect cube. Its cubed root is 2. This is a difference of two cubes. So I make a binomial and a trinomial. In the binomial, I put the cubed root of x cubed in the first spot, cubed root of 8 in the second. Looking at my signs, I'm choosing the top sign plus, because it's plus 8, so I'm going to choose the top sign here, which is plus 2. Then I have a trinomial, 3 terms. And the first position is x squared. So in this case, I'm taking this answer here and I'm squaring it, which happens to be x squared. It's not always going to be x squared. And then I'm going to choose a minus, because once again I had the top sign is a minus. I take a times x. A in this case is a 2, and x is an x. So it's a minus 2 times x, and then plus, because my last sign is always positive, a squared. A in this case is 2, 2 squared is 4. So this is the factored version of a perfect square trinomial. Let's flip to the back and do a couple more. Not a perfect square trinomial, I misspoke. The sum of two cubes. So this is number 9 on the back, perfect square trinomial. Want to make sure our terms are in descending order with respect to the exponents, 2, 1, and 0. Leading term should be positive, which it is. Then factor out the greatest common factor. The GCF in this problem is x squared is 10, so it's 10 times x squared plus 10x plus 25. Then, to see if it's a perfect square trinomial, there's 3 questions we got to ask ourselves. Is the first term a perfect square? The answer to this is yes. The square root of x squared is x. Second question, is the third term, or the last term, a perfect square? Is 25 a perfect square? Yes, it is. Its square root is 5. The third question, if we take 5 times x and multiply it by 2, does that give us the middle term of 10x? Yes, it does. This is a perfect square trinomial. So it factors into one set of parentheses that's being squared. Take the answer to the first question, which is the square root of x squared, and put it in the first position. Take the answer to the second question, which is the square root of the last term, put it in the second position. Put the middle sign of the middle term between them, and this factors into an x plus 5 quantity squared. Let's do another. Make sure your terms are in descending order with respect to the exponents. They are. Make sure your lead coefficient is positive. It is. If there's a GCF, factor it out. GCF here is 1. So to factor this, if it works, maybe this doesn't work, is the first term a perfect square? Yes. Its square root is 7x. Is the last term a perfect square? Yes. Its square root is 4. Is 7 times 4 doubled the same as 56? Yes. 7 times 4 is 28. 28 doubled is 56. So this factors into 7x squared minus 4 quantity squared. And where did I get these numbers once again? And I miswrote that. Should be 7x minus 4, not 7x squared. I got the 7x because it's the square root of 49x squared. I got the 4 because it's the square root of 16. It's minus because this middle term is subtract. The whole thing is squared if it's a perfect square trinomial. Once again, the reason I know that it works, square root of this exists, square root of this exists. If you multiply these square roots together and double it, we get this middle term. So that's how you do a perfect square trinomial. Step 1, make sure the terms are in descending order. It's going to be negative 98x squared plus 200. Step 2, you want your lead coefficient to be positive, and you also want to factor out any greatest common factor. Well, the greatest common factor of this problem is a negative 2. If I factor out a negative 2, I'm left with 49x squared minus 100. Then, to see if it's a difference of two squares, is the first term a perfect square? 49x squared. Yes, it is. Is the last term a perfect square? Yes, it is. Is it a difference? You betcha. So this factors into a 7x minus 10 and a 7x plus 10. Got the 7x because that's the square root of the first term. Got the 10 because that's the square root of 100. And I make 1 plus and 1 minus. It does not matter which is which. Let's do one more. 49x squared minus 100. 49 is a perfect square, so is 100. This is basically the same problem I just did. Poor planning on my part. This factors into a 7x minus 10 and a 7x plus 10. Difference of two squares. Let's flip back to the front and check out difference in sum of two cubes. Supposed to factor this by using the sum or difference of two cubes. First thing I look for is the greatest common factor, as well as making sure my terms are in descending order with respect to one of my variables, and it is with respect to x cubed. The GCF of this problem is a 3y. If I factor that out, I'm left with 343x cubed minus 8. Then to see if it's a difference of two cubes, this is a difference for sure because it's subtract, the first term has to be a perfect cube. And it is. The cubed root of this is a 7x. Is the last term a perfect cube? It is. Its cubed root is 2. So here's how this factors. Bring down the 3y. I have a binomial. In the first position is the cubed root of my first term. That's 7x. Bring down the minus, because it's the same sign of the original problem. Then I take the cube root of 8, which is 2. And I'm multiplying this by a binomial. In the first position is this number squared, this term. It's going to be 49x squared. In the last position, it's going to be 2 squared, which is 4. The last term is always plus. The middle term, if you look back at your factoring sheet on the front, if this is a minus, this here is the opposite sign. It's a plus. What goes in for the middle term, I need to multiply these two terms together. 7x times 2, which is 14x. So this is factored by the difference of two cubes. Let's do one more. This next one, a couple things I don't like about it. The terms are in not descending order. So let's put them in descending order. It's going to be negative x cubed minus 1. I like my lead coefficient to be positive. So I factor a negative 1 out, I end up with x cubed plus 1. So now I like it. Is this a difference or sum of two cubes? It's a sum of two cubes. X cubed is a perfect cube. 1 is a perfect cube. For sum of two cubes, you have a binomial times a trinomial. And for the binomial, you put the cubed root of x of the first term here, which is x, cubed root of 1, which is 1. In the first position of your trinomial, I'm going to take this term and square it. It's x squared. In the last position of my trinomial, it's this last term squared. 1 squared is 1. Last term is always plus. The middle term here is the product of these two terms, which is going to be 1x in this case. And the sign is the opposite of what was in this binomial. So that is factored, a perfect square. Scratch that. It's the second time I said that wrong. This is the sum of two cubes, x cubed plus 1. Please do the homework for factoring by special rules. There are lots of problems, so go ahead and take 2 days to do that. Thank you very much.